Continuing with section 2, this is part 2 of our measuring angles and arcs. So we're going to start out with Theorem 10.1. In the same circle, or in congruent circles, when two minor arcs are congruent, that is going to be if and only if their central angles are congruent. So minor arcs are congruent if their central angles are congruent, which would make sense. So if angle 1 and angle 2 were congruent, or both of them were 40 degrees, because of what we learned before, we also know that arc FG would be 40 degrees because of its central angle, and so would arc JH be 40 degrees. So that's why it's saying that if our central angles are congruent, then our arcs are congruent, or you can say vice versa. Either one of those works. Alright. Finding arc measures in our circle graph. So referring to the graph below, we need to find the measure of KL. So here is KL. Alright, because KL is a minor arc, we know that the measure of our arc, KL, equals our central angle, which is the measure of angle KPL. And we know that KPL is 21% of the entire circle. So if we know that the whole circle is 360 degrees. We can multiply that by 21%, which gives us our degree measure. You can use a percent to find your degree. So when I put that in my calculator, I get 75.6 degrees. So that would be how much my angle equals and my arc equals. So again, you can use your degree that they give you, or your percentage that they give you, to find your central angle, and because the entire circle is 360 degrees, that's how I came up with 75.6. Alright, and let's go ahead and try to find NJL. So I'm going to start it in, I'm going to hit J, and then I'm going to go all the way around to L. So I'm going to go NJL. So I know that that is a major arc. And there's a couple ways you could find this. I'm going to take 360 minus this piece of my pie, measure of angle, or the measure of our arc, NM, and I labeled it with 3 just to be more specific. Now I can find the measure of NML because my percentage is 9% plus 7%, which gives me that piece of the pie is total of 16% right there. So again, I am trying to find this arc so I can subtract it from 360. So going back to look at what we did up here, I'm going to take 360 and I'm going to multiply that times 0.16, which is equivalent to our 16%. So I come up with that to be 57.6%. So NL, or NML, is 57.6% of our entire circle. And to find this arc right here, I'm going to take 360 minus my percentage. So I'm going to have, the rest of that is 304%. So from N, J, all the way around to L, that's going to be 302.4%. Alright. Arc addition postulate, very similar to segment addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Remember, adjacent means right next to. So since XY arc is adjacent to YZ's arc, so I can get this entire arc right here. I'm just going to add XY plus YZ, which would then give me the entire arc that I'm looking for. Again, very similar to things that we've learned before. Alright, so let's use the arc addition postulate. So I'm going to start at L, I'm going to go to H, and then I'm going to go to I. So I would like to look at that right there. Alright, so I know in my picture that LJ, since it goes through the center, is the diameter. And we know that that makes a 180-degree arc. So I know from J all the way around to L, that is 180 degrees. Alright, well I also see this right here, this central angle, which makes IJ arc 90 degrees. Remember, the central angle is also the degree of your arc measure. So I am going to take 180, and then I'm going to subtract, or that's going to equal 90 degrees plus, so my 90 degrees is here, plus I know that HI is 32 degrees. And then I need to figure out what is HL, because that's my remaining piece. And I need to find that because this is what they're asking me to find, is this whole arc right there. So I'm going to subtract 90 and subtract 32 from both sides. So I get HL's arc length to be 58 degrees. So when I am trying to find LHI, that is made up of 32 degrees plus 58 degrees, which would give me 90 degrees. You could have said, well, this is 90, so this portion must be 90 also. It won't always be that simple, but maybe so. All right. Flipping it over to the next page, we need to find IJK. So I to J and then to K. So I need to find this arc length right here. So I know that IJK is made up of arc IJ plus the measure of my arc JK. That equals IJK. So I know that IJ is going to be 90 degrees. So I can represent 90 degrees here, but I don't know what JK is, so that's my question mark. Well, I do see that HK is a diameter, so I can find H or JK by saying, well, I know that my diameter makes 180 degrees. I have HI plus IJ plus JK, that arc. So I can find out that the measure of JK is going to equal 58 degrees. So I'm going to plug that back in here. 90 plus 58 degrees allows me to say that the measure of IJK arc equals 148 degrees. Alright, next, there's a lot going on here, so let's just talk through it real quick. We need to find the arc length, so we need to find the distance of it, and not necessarily the degree. So, the ratio of the length of the arc, L, to the circumference of the circle is equal to the ratio of the degree measure of the arc to the 360. So, here is that in simplest form, like I like to call it. So I'm going to take my length of my arc, which is L, over my circumference, and we have learned that our circumference is 2 pi r, equals the degree, normally that they're going to give you, that central angle or your arc degree, over 360. And I remember that this side is always dealing with my degree portions, and this side is dealing with centimeters, inches, whatever you want to call it, feet. Alright, then it'll make more sense when we get involved. So if you are solving for your circumference, if you're solving for your radius, if you're solving for your degree of your arc, or the measure of your arc, you're going to use the proportion style one. If you're asked to solve for the length of your arc, I always advise you to use your equation portion because it's already solved for L. So these two both are the same thing, they're just set up differently. Alright, so let's try a couple. We need to find the length of dA, so dA is right there, to the nearest hundredth. So I'm going to use my length equals my arc measure, my arc degree over 360, times 2 pi times my radius. So let's just plug in and see what we get. So L equals 40 over 360. Notice my central angle, which is my arc length, times 2 pi, and then my radius is going to be 4.5. Alright, so I'm just going to plug this into my calculator. 40 divided by 360 times 2 pi times 4.5. So my length is going to be, if you want to leave it in terms of pi, 1 pi. So I'm going to divide, multiply, leaving pi alone, 1 pi, which is 3.14 centimeters. Again, you can just punch that whole thing in your calculator. Alright, what if we want to find the length of dA? So remember, length equals my arc degree over 360 times 2 pi r. Well, my arc degree has to match my arc that I'm trying to find. So I'm going to use 180 minus 28 because I need this angle right here, which I don't have. So I get that as 152, which is going to be used up here. So 152 over 360 times 2 pi, and then notice my radius is 6. So if I punch it in my calculator, I would put that times 2 times 6. So my length is going to be times pi. Use your pi button, 15.9 centimeters. Alright, and last, we want to find the length of dA. Notice dA has the angle of 140 degrees. So, remember, my length equals my arc over 360 times 2 pi r. So 140 over 360 times 2 pi times 6, which would give me a length of 14.66 centimeters. Alright, go ahead and pause this video, do your checkpoints, Here are your answers, and I hope this video helped.